So we have this function here. It's find point closest to origin. We have, yeah, this local variable, this local variable. This is technically living on the heap, but it's a pointer, and then size is a local variable. So this is what's happening inside of this function. So on the stack, we have, let's see, closest to origin and current point. I think I wrote these wrong, but you know what I'm talking about. Then we have I. And I think that is, oh, then we have size as well. Size. So that's all like that. And then I forgot to include CAssert. I don't know why. It doesn't need it, but apparently it doesn't. Include CAssert. So here we are again. And then ARR, it's a pointer. It's a local variable, but it points to something that lives on the heap, which is that big long array. Whee! It's very large, so I'm just going to put it like that. And that's what ARR is pointing to, in a sense. Just like we normally draw it like this, but I am going to write this out as we are, just to make it more clear. So then closest to origin is going to start, remember, as the first element. So let's do this just like that. So that's the thing that we think is the closest, this point right here. Remember that ARR is an array of points. And then current point is going to be the first point that we're going to look at and to compare against the thing that we think is the closest to the origin. So that's what this is doing. ARR, closest to origin, going to be the first thing, same as ARR. Current point is 1 next, starting at ARR plus 1. And then size, I think, was 100. I is going to start at 1. And so now, as this function executes, that was a weird 0. As this function executes, we're going to keep on checking and say that it turns out that the current point that we were looking at is a bit closer than the one that we guessed. So what's going to happen is we're going to change closest to origin to be the current point. All right, so that means this is going to go away, and then we're going to start pointing to the same place. Let me actually draw that a little clearer, just like that. Or maybe I don't want to put it inside the box. This is now difficult. And then current point is going to be advanced 1, which means this is going to happen. And I is going to increment as well, I++. And 2, this will become. And now say that this element that we're looking at does not happen to be closer to the origin than the one that we think. So that means we're going to skip this if statement's body, which means we're just going to advance current point again and not change closest to origin because it didn't get any closer this time that we checked. So that's going to happen until, again, we find something that is closer than the one we're on. And sorry, I forgot to change I as well. So now we're looking at ARR 3, which means current point is pointing here. All right? And just for one more example, let's assume that this particular point was closer to the origin than this one. So that means this is going to get updated again. Closest to origin becomes, I don't know how I did that. Oh, go back. Closest to origin becomes the one that we're looking at because of this line. And then we're going to advance I and current point because we need to keep looking. And eventually we'll get to the end and we'll stop all this. And what it looks like when we're at the end is say here's the end of this big long array way over here. Current point will be the last thing, and then eventually I was going to be, or current point is going to actually point one past. Current point will be too far, but we'll stop before we dereference it. And then I will be too big. It'll be maybe 100, because we don't want to access ARR of 100. So that is what's happening there, and yeah, we're going to return the point that we found out was closest to the origin, and if we checked all of them, we're sure of it. So this is the thing that's getting returned. I don't want to draw an arrow, I guess. We return this. Okay, so that is a quick little stack diagram, stack and heap diagram in this case, of what's going on in memory when this function is getting called. So now, the last thing that I want to do is commit all this code to Git, and that'll be the end of it. So, if I say Git and then status, it'll show me that I have not committed anything in this directory. So I can start committing some of the stuff that's there, like the makefile maybe, like by adding it, makefile, just one at a time. So now Git status, it's like, oh, yeah, I'm ready to commit this, but there's some other stuff here that I don't yet know about. Maybe you didn't want to commit that yet, you're not ready, but we are kind of ready. One thing that is a good thing to not commit is the executable files, this compiled code, .o files, and then also this review function. So if I do make clean, that'll get rid of all of that. And now when I say git status, only code and stuff is going to ever get committed. I can say git add dot to add everything in the current working directory. And yeah, every one of these files now has been added. And I can see that by saying git status. And then I can say git commit. And I can give a commit message as well. Added all review files. And git status now is like, ah, yes, there is a new commit. You can look at it. You can look at its name by saying git log. Like, hey, here's your commit. And you can look at the files using other commands that I won't get into. But it's also saying that your local computer knows about this commit, but GitHub does not. You should push it if you want GitHub to know about it. That pushes to the remote branch, and this will now put it there. And then assuming somebody else, like maybe I had a partner do work, I want to get their changes by git pulling. But there's nothing because I'm working on this alone right now. So I think we did everything. So now you have all this code. I'm going to give you this right here. And I think we correctly implemented this program, and it helped us to practice pretty much all of the topics that are listed on that study guide. So hopefully this was helpful to you, and I will see you later.